Alright everybody, you finally made it. It is the last video of your study guide review. Hallelujah. And just in time. So, this skill number 5 of Unit 5 was about Gay-Lussacs law, which describes the relationship between pressure and temperature. And Gay-Lussacs law says that if temperature decreases, the pressure will decrease. And if the temperature increases, then the pressure will also increase. And so when using the Gay-Lussac formula, all temperatures must be in units of Kelvin, just like Charles' law, which we learned about in the video before this. The formula for the relationship between pressure and temperature is P1 times T2 equals P2 times T1. And remember, Kelvin is equal to your degrees Celsius plus 273. So if we look at this first question, it says, what is the final temperature? Okay, so they want to know what is going to be T2. What's the temperature at the end? That was initially at 45 degrees Celsius, so we got our T1. And the pressure increased from 1.4 atmospheres to 3.8 atmospheres. So that language lets us know that 1.4 atmospheres comes first and 3.8 atmospheres comes second. It started at 1.4 and ended at 3.8. So the first thing we have to do is change our temperature to Kelvin. So this would give us 45 degrees Celsius plus 273, which again, I'm going to do in my calculator because I don't want to make a simple mistake in my mental math. So I get 318 Kelvin. And so if I'm solving for T2, I write out my formula because I want to show Miss Nichols or whoever your chemistry teacher is, if you're not actually in my class, you know and what you've learned. And so we know that this is the formula. And we know that if we're solving for T2, that it means I'm going to need to divide by P1 on both sides to get it alone. So T2 all by itself is equal to P2 times T1, which all over P1. So we plug in our numbers. So P2 is 3.8 atmospheres times 1, which is 318 Kelvin, which remember, this will not work if you use it in Celsius. And P1 is 1.4 atmospheres. So our atmospheres will cancel out. And again, we do this in our calculator. We multiply the top first, so 3.8 times 318 equals 1,208.4 divided by 1.4 gives us, it gives us 863.1 Kelvin. Excellent. And again, they don't ask for our temperature to be in degrees Celsius, but if they did, we would just subtract 273 to change the unit of our answer. So, again, just like in the previous video, go ahead and pause the video and then work out question number 2. And when you're done, press play, wait a few seconds, and the answer will pop up on your screen. Alright, so now that you've checked your work, you can, now that you've done the work, you can check it with what you see on the screen. You should have gotten 4.72 atmospheres for your answer. So pause the video and kind of peruse it if that is not what you got, so you can identify your mistake and not make it tomorrow on your exam. So the last thing that we need to go over is the ideal gas law. So the ideal gas law describes how pressure, which we know has a symbol of a P, volume, moles, which is symbolized by the letter N, and volume, which that should have a V there, are related. The formula for the ideal gas law is P equal to moles times R times T. Now you might be saying, Miss Nichols, what is R? R is a gas constant. It's 0.0821 liters times atmospheres over moles per Kelvin. This is something you are expected to just know. It is always the same. That's why we call it a constant. It's the same for every problem. So if we look at question 1, it says if I have 3.8 moles. Remember, moles is symbolized by the letter N. So this is N. And as soon as you see N, that means you're using this formula because that's what we need. And it says we've got a pressure of 5.0 atmospheres and a volume of 3.6 liters. So we've got ATM is pressure, liters is volume. And then it says, what is the temperature? Okay, so T is our question mark, but it says in degrees Celsius. So our answer cannot be in Kelvin. They want our answer in degrees Celsius specifically. Now, when we do this, it's very critical that you're paying attention to your units, because if my formula is P times V equals N times R times T, okay, and I'm trying to solve for temperature, that means we divide by N and R on both sides to get T by itself. So T is equal to P, pressure times volume, divided by moles times R, our gas constant. So if we plug this in, okay, pressure is 5.0 atmospheres. Again, I'm writing my units. Volume, 3.6 liters. I'm not just writing 3.6, it's 3.6 liters. Times my moles, 3.8 moles. And then I'm multiplying by R. Now remember, R is your constant. It's always the same. 0.08 liters times atmosphere divided by mole times Kelvin. Now I know you're like, Miss Nichols, why does this number have 4 units? I know, it's kind of crazy, but look, when atmosphere cancels out with atmosphere, liters cancels out with liters, moles cancels out with moles, and this is how you know that this temperature, this answer we get, is gonna be in Kelvin. Okay, so I'm actually gonna do this in 2 steps. I'm gonna simplify the top first. So because we have 2 different sets of multiplication, so doing this correctly in our calculator is really important. So 5.0 times 3.6 gives us 18 for our numerator, and 3.8 times 0.0821 gives us 0.31198, and I'm trying to write it all down because I want to be as specific as possible. So 18 divided by 0.31198 gives us 57.7 Kelvin. Now it's super tempting to just make Kelvin degrees Celsius because that's what it's supposed to be, but in order to actually change it to Celsius, because our answer or our question says in Celsius, we would need to subtract 273 to get Celsius. So 57.7 minus 273 is a negative 215.3 degrees Celsius. So this temperature is very, very cold, and that would be our final answer. If you were to stop here, you would still get a majority of your points, but you would definitely get points taken off for not changing to the correct unit. So what I want you to do is I want you to practice question number 2. So pause your video and then work out this problem on your own. Then press play and check your answers once it appears on your screen. All right, so you should have gotten 33.16 atmospheres as your answer. Go ahead and check your work. Make sure you plugged everything in correctly, and that you used your calculator correctly, that you multiplied the 3 numbers at the top and then divided by 2.0. Now, the final thing is this gas law chart that kind of summarizes everything and puts it all in one place. So Boyle's law's formula is P1 times V1 equals P2 times V2. Charles' law is V1 times T2 is equal to V2 times T1. Gay-Lussacs law is P1 times T2 is equal to P2 times T1. And the ideal gas law is P times V equals N times R times T. And remember that if you need to use that, R is equal to 0.0821 liters times atmospheres divided by moles times Kelvin. All four of those units for that one number. And as a reminder, pressure has a unit of atmospheres. Volume, which that should have a V there, volume has units of liters. Temperature is degrees Celsius or Kelvin, both of them. And moles has the unit of, well, moles. And that is the end of your study guide. Hopefully you feel confident and ready for your chemistry exam.